you want to be an Azure data engineer, this is the perfect tutorial for you. In today's video, we're going to create an end-to-end data engineering project in real time in Azure. Now, you don't have to have any experience. This is all from scratch, and I'm going to teach you exactly how do services talk to one another, why security is so important, as well as covering the main services asked in every Azure data engineering job. We're going to look into Azure Databricks for distributed data processing and transformations, Azure Data Factory for orchestrating data workflows, Azure Data Lake Storage for scalable data storage in bronze, silver, and gold containers, leveraging Medallion architecture, and Azure Synapse Analytics for querying and analyzing processed data. And I'll also show you at the end a little on how to use Power BI so that you can really visualize and understand this data. Now, let's get into the video. So welcome to the tutorial. We're going to be working from this GitHub repo here, which is my repo. Within here, we have a README, which is this here what you're looking at. We then have a detailed step-by-step guide, which is what I'm going to be following on the other screen. And this here tells you everything you need to do. So you could literally just follow this guide, not watch the video, and get on with it. And then additionally, we have the notebooks, which are the notebooks that we have that we're going to use within Azure Databricks. So the Python notebooks we're going to use for the transformations. So without further ado, let's get into it. So we're going to create a data engineering pipeline, specifically for earthquake data. Now, if you think about it, whenever you do projects like this, especially if you're going to use them to try and get a job, you really want to be using or creating a project which has some sort of business use case. So how does an earthquake data pipeline have a business use case? Well, earthquake data is vital for understanding seismic events and mitigating risks. Stakeholders such as government agencies, research institutions, and insurance companies rely on accurate, up-to-date info for planning emergencies, assessing risk, and making data-driven decisions. So imagine, for example, you're a government. You want to know what's the likelihood of an earthquake and how bad is it going to be, and you want to see how has it happened in the past so that you can predict it in the future. Also, insurance companies, if you're going to insure a house, say, how likely is it that it's going to collapse due to earthquake, for example. So there is a business case here, and that is the business case. So as for the pipeline architecture, what are we actually going to do here? Well, we're going to use an API endpoint to get the data. The data is going to be ingested into here, which is an Azure Data Lake, which is a type of storage within Azure. Within Azure, you get your storage account. Don't worry, we'll go into this. Get a storage account. Within your storage account, you get containers. One of the containers we're going to use is this here, the bronze layer, because we're going to use a Medallion architecture. Again, we'll get to that in a bit. But basically, we get data from the API, we ingest it into this container, we do some transformations in Databricks into the next, transformations again into the next, and gold is, boom, we have the perfect data for the business. Now, this is automated using Azure Data Factory, and then we load the data into Synapse Analytics. Now, this is so that we're abstracting the calculations and like the SQL queries up into a specific platform. And then from here, we can say create views, which we can then publish so that we can then access the data for visualization, say in Fabric or Power BI or Tableau. And I say Fabric here because Fabric has an integrated Power BI within it. So that's the general architecture. So we're going to be creating these resources here in the cloud. So we'll get to that soon. Right, prerequisites. Set up an Azure account. So first things first. I'm going to start guiding on this screen, and we can follow along on this screen. So if you don't have an Azure account, we'll go to the guide, sorry. If you don't have an Azure account, you can set one up. So create an account, just go to this link here, or just search it. Get started with Azure. Try Azure for free. And then for me, it will just try and log me in. But what you will get when you click on that, it's taking ages to load, $200 of credits. So this will make this tutorial completely free. And additionally, you'll get free monthly amounts for some services, free monthly amounts for always free services, etc., etc. And obviously, no upfront commitment, cancel whenever you want. So go and sign up for an Azure account. If you already have one, consider making another one for a different email. I don't know. I didn't say that, but you could. So anyway, now you have Azure. What do we do? Let's set up some resources. Now, if you know the channel, I don't like clicky, but it's the best way to learn. Click ops, we call it, which is where you click to make things. As a cloud consultant, cloud engineer, you're taught to always use infrastructure as code, which is code which does all this for you. But to learn it, you click first. So we'll do this tutorial, clicking, and then the next tutorial, I think we'll automate it using Terraform. So we'll have the entire thing, you just click a button, bam, the whole infrastructure is up and running. So anyway, need to create an environment. So first, let's set up Databricks, because this will probably take the longest to create. So you click on Databricks, or you go to the top and we'll search Databricks. We have this here. Click on Databricks, and then you can either click create here, or if it's your first time here, click that. So just create. And then from here, you'll have project details, which you have to fill in. Now, subscription refers to which Azure subscription you're using. A subscription is like a logical grouping. You'll probably only have one, and it will be the free one, most likely. If you're working for a company, they can often have different subscriptions because it's like a logical grouping for management, security, billing, etc. So you could have a subscription for, say, different applications or different divisions. And then under that, we have resource groups. Now, this is a way to logically group together resources within Azure. So, for example, all of the resources we're going to create today, we'll create it in the same resource group, because that way it's all there. If we ever want to go and find one, we'll just go to the resource group and we can see them all. If we want to delete the entire project at the end, because you don't want to leave it up and running, because it will just start accumulating cost, then we want to delete the entire resource group in a oneer, and we can do that, and it deletes all the resources in the group. So if you click here, you can select one. We're not going to select one because you won't have one, or you'll probably have that network watcher, but you don't have anything else. Let's create new, and we'll call this data look. We'll just call it data look. Click OK. Name the workspace. We'll just call this data look. So this is just the name of the Databricks workspace. Doesn't really matter what you call it. Region, we'll just leave it in East US, and we'll do premium so we can use role-based access controls. So within Azure, and we'll get to that in a bit. I'll open up Excalibur so we can start. Oops, Excalibur, which is a nice handy platform. This is from when I was brainstorming before. But it's like a whiteboard that you can use online. Really handy. Check it out. Yeah, anyway. So you have role-based access control. You'll sometimes hear it called like RBAC. Essentially, when you have, say, a person, that looks like a mushroom, but that's a person. And then, what's that? That, or say you have, say, a service, right? We'll just do a box to indicate that. Well, when you want the person or the service to get access to something, so they want to go through this door will only allow in people that have a specific role. So say the role would be allow in, right? So if these two down here want to go in this door to use this service, so say this is you, the user, or this is Databricks or whatever, right? And you're wanting to connect to something else, then role-based access control is you then give these guys a role, this role, the allow in role, for example, and then they're allowed in. Whereas if you remove the role, they're not allowed in. And the best way to manage this is often in groups, not as users. Because if you assign it to the person, then you assign it here, then suddenly you're going to have to undo this one and undo this one. Whereas if you can just assign it to the group and then call this group, I don't know, devs, then anyone in the devs group automatically is allowed in. Simple, right? That's RBAC in a nutshell. Let's delete all that because I don't need it. So anyway, back to this. Premium role-based access control. And then from here, you can just review and create. Just jump straight to the end. And then create, because we don't need to worry about networking, encryption, security, tags, etc. for this specific tutorial. So now it'll go to this screen, and this is where your deployment is now in progress, and it will just sit here doing this, and it will tell you what resources it creates under here. Because, for example, Databricks has a bunch of resources that it creates. It doesn't just create a Databricks workspace. It has to create the underlying services, because if you think about it, for Databricks, you write code. That code has to run somewhere, so it runs on compute, which is allocated by Databricks. We can have a look at that in a bit. But anyway, this is now is a screen on Azure. It's creating the resources. You can see up here we have a notification icon with loading. That's because the deployment's in progress. That will tell us when it's done. So in the meantime, let's create the storage account. So if you recall from the diagram, so if we go back to the GitHub repo, we can see from this architecture, these three containers, they're all in a storage account, because a storage account is where you keep all of your stuff that is storage related in Azure, within reason. You know, if you're going to use a SQL specific service, then that's not within storage account. However, within your storage account, you can have files, you can have queues, you can have tables, you can have containers, etc. So I've just clicked create on a new storage account. Again, same subscription. For resource group this time, we're going to use the same one. Doesn't have to be the same one, but we're going to make it the same one. You can see you could have a resource group for all your storage accounts. Don't know why, maybe you would. So storage account name, we'll just call it data. Wonder if that's available. No, because it has to be a globally unique name for a storage account, because storage accounts, you can get to them via URL. This. There we go, that's fine. Region, do the same region, that's fine. Primary service, now we'll click Azure Data Lake Storage Gen 2, because that's the primary service. That's what these containers are here, as we've just spoken about. ADLS G2, Azure Data Lake Storage Gen 2. Performance standard, that's fine for us. Redundancy, now for resources in the cloud, part of the benefit of being in the cloud is redundancy that you can leverage. So if you have a data center, say at home, you have your laptop, you have stuff in your laptop. Laptop breaks, stuff's gone forever, right? You could have a backup laptop, you could have that in your house, but then if something happens to your house, both of them are gone. You could have a backup laptop in someone else's house, but then say both of these houses are within the same street, and something happens to the street, then they're both gone. Well, instead you could have one on a laptop which is in someone else's house, which is in another city or another country. So these are the layers of redundancy that you get. And within Azure, it's locally redundant storage, LRS, geo-redundant, zone redundant, and geo-zone redundant. For us, we'll just leave it as GRS, that's fine, but we don't care because it's just a tutorial. But in practice, you would want to do this relative to, how much failover can you really accept? How much downtime can you accept? What do you want to hedge against? So we'll just go with that, that's fine. Click next. This time we're going to go to advanced, because we want to enable hierarchical namespacing. Now that's to facilitate data lake storage. And click that, enable hierarchical namespacing. Now we'll just go straight review and create, and then we'll click create when it validates. You can see it's now initializing the deployment. So we've got to this notification, we'll have seen that the Databricks one has successfully been deployed. That's good. Let's go to the resource and we'll check it out. So in the Databricks resource, we can see here that we have this managed resource group. Now don't worry about the other stuff, we'll get to that when we get to the Databricks portion. Let's just look at managed resource group. So this is what I was referring to, where Databricks requires its own resources, and that is within a managed resource group, managed by Databricks, not by us, so we don't have to worry about it. And this is what it creates: managed identity, storage account, access connector, which we'll be using, network storage group, and the virtual network. So that's just kind of for your information. If you want to look more into it, you can. Oh, and there we go. Storage account is now up, so go to resource for that one. You can see this here's your storage account. Don't get overwhelmed with all the data. once you've seen it a handful of times, it'll all seem pretty obvious. You have the essential stuff up top: resource group, location, primary, secondary, subscription, ID, performance, replication, blah, 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 right? A bunch of stuff. We don't really need to know about any of this, not for the tutorial. But on the left-hand side, you can see we have this data storage option. And within here, you have the types of data storage that we have enabled within storage count, or what we have available. Containers, file shares, queues, and tables. We're going to create containers, as you can tell from the logo. That's the same icon as here, because it's just a container that we're going to use. So you'll see that it automatically has a container, log container. We're wanting to create 3 containers: bronze, silver, gold. So click plus container, got bronze, oops, and then just create, and that's your bronze container created. We'll do the same for silver, create, and we'll do the same for gold, create. And now these are the containers that we're going to be putting information into and taking information out of in Databricks. The bronze being the raw data straight from the API, so the JSON gives us the API, put it straight in the way it is. We'll then clean it, tidy it up, move it into silver, and then based on this clean data, we will now then get what we want for the business case and then put that into the gold. So before we do that though, another thing we have to create, which takes ages, is Synapse Analytics. So Azure Synapse Analytics, click here, we'll click create. And the reason I'm doing this is because then when we come to use it, it will already be there ready for us to use. Same as normal subscription, resource group, we're just going to do the same as normal, that's fine. Manage resource group, let it use its own if it wants one. Workspace, we'll just call it data lake for no particular reason. But which data lake do you want to attach to the Synapse Analytics workspace? We're going to attach data lake 123, which is the one we just created. And which file system do we want to use? We will create a new file system, and we'll just call it Synapse FS. Click OK. And then we want to assign ourselves this storage blob data contributor role. So if you recall from the RBAC explanation, we want to have a role, which is the storage blob data contributor role, so that Synapse can interact with the data lake using our role, because we'll be doing the stuff on it. So that's good. And then we review and create. Then I'll do the same thing again, and we just click create. Do note here, 5 USD. So that's the cost per terabyte for this serverless SQL. So when you run queries, per terabyte. So if you're using this for the first time, you have your $200 credits. Don't worry, you could use like $195 worth of credits and you'll be fine, because that's going to be a lot of queries. But if you're not, still don't worry about it, because like at most, what's it going to cost you? Maybe a couple of cents to run like a day's worth of queries. For what we're going to do, you'll probably use like a cent or something. So anyway, let's just create that. Just wanted to flag it though, because when you see the 5 USD, you're like, wait, it's going to cost me a $5 to start this? No, because it's compute resources, it's, the model of the cloud, pay-as-you-go essentially, operational expenditure. If you use it, you pay for it. You normally don't pay to make the thing, you pay to use the thing. So that's deploying, that's cool. Right, let's jump into Databricks. So up top, and just search for it. It'll be here in your recent, and you'll see this one. That's the one we want. Click on that. And from here, we want to launch our workspace. And then just pick your account, and it will log you into the workspace. Because Azure Databricks operates like a separate app, as does Data Factory, which we'll create when we get to that. No reason to create it now, doesn't take long. And then the Synapse Analytics one as well. They're their own like applications essentially. So when you come to Databricks, this will be what you see first. Again, Don't worry too much about what you see on screen. We're only going to cover a couple of things. Mainly, up the top here we have our workspace. So this workspace is where we're going to store the notebooks we're going to use. We then have catalog, which is where we are going to connect the data lake storage, because we want Databricks to be able to talk to and communicate with the data lake storage so that we can manipulate data, push data, pull data, etc. We then have compute, where we're going to be creating the compute to run our notebook, because as I said, notebook's just code, it has to run somewhere. And it doesn't just run on Databricks, because that managed resource group you had just seen for Databricks essentially is to like run the Databricks application, as far as I'm aware. So you have to actually create the compute that you want to use for your notebook. So if you're doing like a massive data pipeline, you may want to use or leverage distributed compute so that like if you have, I don't even know, a number, set billion or whatever, right? If you have one with a million zeros after it or something, number of rows, and you want to split, you don't want to just process them top to bottom, 1, 2, you'll be there all day. So you want to split them up on different computers so that each computer can process a batch of them or a number of them, a portion of them, right? And that will speed it up. Because if you think about it, if you have one person doing calculations on a calculator and then another person doing calculations on a calculator, it's going to be, half as long as if just one person was doing it. So it's similar type of principles for distributed computing, and that's where PySpark and Databricks work so well, is when you're scaling up that they can scale up with you. Whereas for what we're doing, you don't really need it. It works perfectly fine in Microsoft Fabric, because this tutorial, I've already done it in Microsoft Fabric, so you can go and check it out if you want. Much simpler, but these are the tools that you're going to be using if you want to be an Azure data engineer. So now that we're here, we want to create a compute instance. So click create compute. And this will be the screen you'll be given. From here, you can also actually, top right, UI, you can change that to JSON if you want. You can change it from here. If you want to just change it programmatically, we'll just go with the UI, because it'll be simpler, especially if you're not too familiar with coding. So my cluster, that's fine. Policy, unrestricted, that's fine. We want it to be single node, because I don't think multi-node will work with your free trial. So single node. Access mode, single user, that's fine. Databricks runtime version, we want to use a long-term supported version, so an LTS, that'll be fine, 15.4. Photon acceleration, we're not going to need that. Node type, so here you can click, and node type is essentially like what spec do you want the computers that run this stuff on. And for us, we're just going to use a general purpose. We'll use the smallest one they have, because we don't really need any processing power. 14 memory, 4 core. Click on that. You can see that will let us do that. You can, and this is how, when I'm talking about scaling up, is if you scroll right down, you can see you have like GPU accelerated compute as well, memory optimized, etc., etc. But we're just going to use the standard one. And then we have this terminate after X number of minutes of inactivity. So this is because you're spinning up clusters of compute resources and you're allocating them and doing calculations on them. This is going to cost you money. Now, you don't want this to be sitting, say like your calculations, say you only run your pipeline Monday to Friday. You don't want this pipeline to be sitting all weekend hogging up some super expensive compute resources if you're doing like some of these more optimized GPU ones, because that would cost a lot of money. So instead you want to terminate after so many minutes of inactivity. So for this tutorial, are you going to leave, go get a cup of coffee, go to the toilet or something? You're not going to be longer than 30 minutes, for sure. Maybe longer than 15, but not longer than 30. So we'll do that, which means that it will terminate the instances of the compute resources. Now, the reason that this is worth noting is because the compute can take like 5 to 15 minutes to start up, because Databricks has to go and get the resources, allocate them, blah, 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 sort them out, get them all in line, get these ducks in a row. And now, you and my cat meowing. I'll get it in a minute. 2 minutes, Misha. But basically, it's going to take like 15 minutes max, maybe 5 to 15 to spin up this cluster. So you don't want it to terminate when you're away, getting a coffee, come back, then you need to wait 15 minutes to be able to run your notebooks. So anyway, let's click create compute. I'll let the cat in. I'll be back in a sec. So I'll start spinning up. Let's go back to Excalibur. So you have your storage account with your containers, right? Right. And then you have your Databricks instance. Now, although they both live in Azure, kind of thing, they can't automatically communicate to one another. Because if they could, think of the issues you would have if you have a bunch of storage accounts and a bunch of Databricks notebooks, and they could automatically all talk to one another in some sort of like, dodgy topology. I'm not even going to try and draw it, but you get the gist. And then they can all just talk to one another. So as you can imagine, this has caused a load of issues, because say this was dev, say this was production, say this was QA, say this was actually a completely different application, say it was users' data or something, right? So as you can imagine, it gets all a bit messy if you're to let them automatically communicate to one another. So in my previous tutorial, someone had said it seems like a bit of a mess in Azure. Now, the reason is because of that, because you don't want services to automatically communicate with one another, because you're not using like one entire Azure subscription for one application, for example. And even still, if you were, that application doesn't, not all the components of the application require connections to one another. So you want to have that principle of least privilege, which is a standard security principle, basically to say that you should only have as much privilege as absolutely necessary to complete your job, not anymore. So if you need to read and write, but you don't have to, manage who else can read and write, should you really get admin privileges, or should you have a specific role which allows you only to read and write, for example? So anyway, you have this storage account, you have your Databricks, they must talk to one another. Now, one thing to note in Azure is that when they have to talk to one another, there is a door on either side. Not literally, but you can think about it this way. Which means that if you, on the Databricks side, connect to storage account and say, yeah, cool, storage account is connected here, that doesn't mean that it's going to work, because you then also have to connect it from the storage account side as well to say, basically, on the Databricks side, you're like, cool, yeah, my door's open for storage account. But then you have to be able to have storage account's door open to let Databricks get the information, type of thing. So how does this practically work? Well, we have our cluster here. That's cool. Now we want to connect to this storage account. And what we do is we go to catalog, and from here we go to external data. You can see I've got a bunch here. You won't have any, but I've done this before, and it saves the data. We first want to go to credentials. We want to create a credential. Now the credential type is Azure Managed Identity. Because these are both in Azure, you can just let Azure manage their identity. Basically, their ID cards, they can be sorted out by Azure. But this credential name, we'll call it data look. Actually, I don't think it'll let me because I've already got one. Call it data look 2. And then the access connector ID, this is what I was referring to. If we go back to the portal, the Databricks here, you can see that we have this managed resource group. If we go to that managed resource group, and then we can see that we have this Unity Catalog Access Connector. Now this can also be found if you search up top, Access Connector for Azure Databricks. If you click here, the exact same things come up. But we'll go with this just so I know which one I'm using. We click on it, can then see that it has a resource ID. This here is the connector ID. So if you hover over it, you can see the little copy logo comes up or icon. Click on that. Go back here, paste that in, and that's now your access connector ID. Click create, and this will now create a new credential that can be used by that connector. So where do we want this credential to be used? We want it to be used for, go back to external data, external locations. Specifically this bronze, gold, and silver, or these bronze, gold, and silver locations. Now the way that you do this, and I'll go in and edit them, but I'll show you how to create one first, and then you can create one for each of bronze, gold, and silver, is you click create external location, and then the external location name is whatever makes sense. So for us it would just be bronze. And then the URL here, it has to be in this format, abfss :/ the container name, which will be bronze, at the storage account name, which for us is datalook, .dfs.co.windows.net. And now that is the endpoint that we're going to use to get to the container. So after you have then written that in, you then get the storage credential, and for us this is where we're pulling that credential we've just made, which for me is datalook2. But in here it would look something like this. So like abfss / bronze at dot, something like that. And then you click create, and then it will create it for you. And now you have to do this for bronze, silver, and gold. You may get a complaint initially. I'll go in and edit mine just now to show you, because it might come up for me. So if you ever have to edit one, click on it. You're in here now. If you then click on 3 dots and then edit, then from here I'm just going to change this to datalook. Copy that, and I'll change the storage credential to my new one and update. We'll see if it comes up. So yeah, I thought something like this may happen. So this is just double checking the path, blah blah blah. Bronze at datalook. Let me check this. Oh, datalook 1, 2, 3. That's what it was. 1, 2, 3. That's the new one we've made. An update. But it's still making up with an error. There you go here. But this is just because your container is empty. So, because as you say, this may be due to the location being empty. So just force the update. Then that's that. And then we'll just do the same for silver and gold. Datalook 1, 2, 3. Then the same credential, update, and then I'll have to force it. And finally the same again for gold. And there we go. So now that we have these sorted out, it's time to create the notebooks. And then we'll run the notebooks. I'll show you that it's not going to work because we've only opened one door, and then I'll show you how to open the second door. So in reference to this here, you on the Databricks side said, yep, connected, all good. However, here in front of this door, I suppose I should do it probably in a different color. Let's do red. In front of this door, you have I am in Azure and are back. Thing that we're talking about, the roles. So we're going to have to go the storage account I am, and then we're going to have to give this Databricks a role. Oops, disappeared. But anyway, we'll get to that. I suppose let's just do it now. So if we go to the storage account, storage accounts, go to our storage account, datalook 1, 2, 3. And then from here, if we go to I am, so this storage account, we'll go to I am, which is your access control. You can see here, you can check access, blah, blah, blah. Role assignments, that's the thing that we are concerned about. If we click on role assignments, you can see that there will be some roles assigned. However, or you may not have many, you may only have you as owner, but I've had a few. We want to add a new role assignment. So we click up the top here and add, and then add role assignment. And now from here, we can select one of the roles. So for us, what we want to add is storage blob. So we want to storage blob data contributor, because ultimately the storage that we're leveraging is blob, binary large objects. So storage blob data contributor allows for read, write, and delete access, because that's what we want Databricks to be able to do, to be able to write, to be able to read, and possibly delete, sure. So click on that, and then we click next. And so now we have to assign it to someone. So we have user, group, or service principal, or managed identity. If you recall from the explanations, we're using managed identities for these services. So click managed identity, and then members, we'll select members, and it's from our subscription. The managed identity is this access connector for Azure Databricks. For here, I have two, you only have one. It's not very handy, and it gives me almost the exact same one. How am I gonna know who's who? What's the difference here? Subscriptions. So this is the resource ID we're seeing. So if I open this up, it's just so you can know, I suppose, then, if ever you encounter this issue, is if we go to Databricks, data look, the managed resource group, that's just so I make sure we're going to the right connector, because they just have the same name, connector. Click on the connector, and then we have this here, that's the resource ID. I don't know if I can copy by that, if it won't let me because it needs the name. Oh no, there we go. Click on that one, select. There we go. Now review and assign. Review and assign. And that's it, assign the role. You see it will come up twice here. That's fine, just refresh it. It's a quirk of Azure. And then it comes back down to 1. So, all good. We now have the I am on this side too, which means that this two-way communication channel should be all good and approved from both sides. So now let's finally get into the meat bit here, which feels weird saying it as a vegan. Hey, whatever. The main portion. Bronze, silver, gold. So go to Workspace and let's set up our notebooks. So from the Workspace here, you can organize your Workspace however you want. For me, we're just in Workspace and users and then me. We can create, like, say, a folder in here if you want. We could call it like earthquake data, but we're just going to go straight to here. No folders, just straight to the notebooks. So click on notebook. And it will take you to here, which is an IPython notebook. So you'll probably know it from Jupyter notebooks, etc. Oops. But an IPython notebook is an interactive Python notebook. Because it's an interactive notebook, it's not just code that you run. You don't run it with, Python 3 command or something. You can run it directly in the notebook. So from here, I'm going to open this up another page and we'll copy and paste lines of code in one at a time. Now, I would strongly suggest that you don't just go to this GitHub here, right? Don't just go to the GitHub, download the file and upload the file, because you won't learn anything. Ideally, what you should do is read what I write on screen, listen to what I'm saying, and then type the code out yourself. Get the muscle memory on your hands, but additionally try and remember entire lines or entire chunks of code and then write them in a one, because memory comes from recall, not from doing per se. So that's how, like, you could just sit and transcribe audio all day and never remember a word. It's more about, if you listen to audio, then stop, then try and remember it and write it, you'll remember that much better. That's a tip, actually, if you're studying. I used to do that, so, I'd be like at school or at uni. If I see a slide on screen, I'd try and remember the entire slide and write it all out entirely in a one, or as much as humanly possible, before I'd look up again, so that I would then do active recall as I'm essentially reading it and writing it. So anyway, back to this here. The bronze notebook, let's pull it in one part at a time. So the first thing we have to do is, or I suppose, let me give you a quick rundown of Databricks Python notebook. This here is your notebook up top. We can rename it, so let's rename this to bronze notebook. To do it, you just click on it. As you can see, it's a Python notebook. You can have it as Python, SQL, Scala, or R, but we're just going to do Python. That's then why it's going to be an IPython notebook. You see that as like file names. It's like i.ipynb, which is an IPython notebook. Anyway, so from here, file, you can get a new notebook, import, blah, 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 export it as IPython notebook. That's how you get it to then put it in the GitHub, for example. Edit stuff, blah, blah, blah. View, run. This is handy to know. Run and debug. You can run all the cells. A cell, I'll get to in a moment. But you can run all the cells. You can run selected cells, run the cells above where you are, below where you are, etc. And you can clear as well, so that like you can get it in a nice format if you're going to save it. Because when you run something, the output comes directly underneath it. So within here, we have this, which is a cell. A cell can be code or text, whatever you want it to be. Within here, you just do one thing normally, or like one set which moves you kind of one state forward or one state in one direction. So basically, using different code cells like this, so you can see it's code or text, you're able to then divide it up such that each cell can run logically distinct from one another, meaning you can track errors and stuff and change much better, much faster, do things on the fly, check things out, debug, etc. And if you want to just run all of them, you click run all. And up here as well, you have connect. This is where you connect the cluster where you want this to run. So first things first, our first chunk that we're going to add in is this here, which we're going to mount the Azure Data Lake storage. Now we're going to do that via this same path, so that ABFSS path. You can see I've just separated out, we've got bronze, silver, gold, and then we just inject it into here in 4 tier and tiers, and then that creates like an array of that in here. So this is a winner for that, and that. Now that's just so that we don't have repeatability, or we don't have repeated code, because standard software principle, dry, don't repeat yourself. If you are going to write the same thing or same portion of a thing again, and you would want them, if you were to change one, it would change the other, then you should always variabilize it. Hence this here is that if I'm going to change this, instead of having to change that 3 times for bronze, silver and gold, I'm just going to change it once for here. So if we run this, block notifications, it's getting those paths, and then it's putting those paths in as variables here, and then showing them out here, but we don't have anything in them, so nothing to show. Now the next part we're going to add is a couple of imports. We're going to import requests, JSON, and datetime. We'll just play that, and I'll show you why we're going to do that in a second. So we have this here, the understanding the API. So the Earthquake API provides detailed seismic event data for specified start and end date. So if we go to this API URL here, let's copy and paste that in. Go here. Now you see this is the API documentation for this Earthquake catalog. So it's USGS, and they have this here, a query endpoint, like an API, to submit data requests. So you give it in this format, HTTPS, Earthquake, blah, 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 query, format in JSON with a start and end time, and it will give you back all the information about earthquakes that have happened during that time, or seismic events. So that's the kind of query we're going to use. So let's get back out of Databricks, now that that makes sense to you. So the next piece of code we'll do is the start and end date, because as you recall from that API, we require a start and end date. And so for that, we do start date as today minus, and that's why we pass in this time delta, minus 1 day. And then the end date is today. So from yesterday to today, get all those events. So let's run what we have so far. So we've run that, let's run this. You see there's no output, but the beauty of like using a notebook like this is we can then paste in or write something like that, like start date, end date, play, and it'll give you the values. So you see how handy this is to use on your day-to-day working. So that's our start and end dates. That's cool. Next chunk we'll add in is this here, which is going to get the data. So looks a bit confusing, don't worry, it's mainly because it has a try and accept and stuff. It's trying to handle errors essentially. But we first construct the API URL, so actually let's put that into its own little code block. So we have the URL equals, and then we have this F, then the URL, and then we inject in these variables into the string. So this here is a string. This F denotes that we're going to inject some variables into the string. And then this is how we do this. Color braces with a variable name inside it. So if we click play on that, that will then assign this variable and initialize it. And if we just put URL and play that, oops, we can then see that it's created that URL with the start and end date, which is perfect. So next we want to use that URL and we're going to try and get back data. So we're going to hit the URL endpoint and see if it gives us data back. And we have a try and accept here to basically say, if it doesn't work, let me know. Don't just kill the program. Let me know it's not worked and try and give me the error message. But the main thing here that we're after, that we're concerned about, is we have a data variable, which is the response, the JSON response that we get from getting the URL. So it's HTTP GET request, so getting data from this URL. And then if there's no data, it says there's no data. Otherwise, we create a file path of where we want to store this data. So this is our bronze layer. So we want it in the bronze ADLS, which is, we scroll up, the endpoint of that with bronze in it. So the bronze container. Go to that bronze container, create a new file with the start date, because if this runs every day, we want raw data for every day. And you may want to store it so that you have like the historical data there. So then we want to save the data. And we have this JSON data equals JSON.dumps, and we're passing in the data. And then DP, which is Databricks, utils, FS, which I think is file system, and put. So create a file at that file path with that JSON data. And if it exists already, just overwrite it, because we're going to make a new one for each day. So if we get it again that day, and it's more up-to-date data, then just overwrite it. So if we go to portal here, and we go to storage account, and we'll go open up our storage account, data look. And then from here, data storage on the left, go to containers. And then let's open up our bronze container. See, there's nothing here. So we'll go back to Databricks and let's click play on that. And then that's it done. Wrote 351,000 bytes. Data successfully saved to here. I won't be able to get it from the internet. But if we go back here and refresh, there you go. See the JSON file now exists. And if we click on that, we could download it and open it. Or within Databricks, we can just click code here. And a way to look at the data that had come back, so this response piece here, is if we do data, I'll show you what that is. Click play. See, this is the data that comes back. But this will have everything that's come back, like, so all of the data, right? We just want, say, the first one, so we can just validate what is one item that comes back. If we do 0, that's indexing the array to just get the first one, and this here's the first one. So as you can see, this is all the data that comes back, which is perfect. That's what we're after. So now that we've done that, that's the bronze notebook sorted. We will come back and change this so that every day this can be dynamically changed from the data factory. Now, it doesn't necessarily need to be done, but it's just to show you how you could inject variables into here and get them back out. But this looks good as is. We'll come back and modify it when we move it to data factory. So bronze, perfect. Let's now go back to Workspace, click create, notebook, and then we'll do the silver notebook. We could also, for reference, file, and then new notebook. So 6,500. Anyway, silver notebook. So the first thing we do for the silver notebook is we're going to assign from date time, we're going to import that, and then we're going to assign the start date, the bronze, and the silver ADLS. So as you can see, it's like this. Now, I'm copying code. If this changes, that one changes. I shouldn't be doing this. No, I shouldn't. And that's why in Data Factory, we're going to leverage passing variables from one notebook into the next, so that we don't have this repeatability, so that we can just write it once and reference it thereafter. But for the tutorial right now, so to get each of these notebooks to run independently of one another. We don't reference the values from the other one. So we have, say, we have notebook 1, 2, and 3. When you then put these into Data Factory, you can then pass the variables from there to here, and from here to here, and from the first one all the way to here. However, when you're just working straight from Databricks, it's much easier for us to just look at this as an isolated block and run it on its own. So that's what we're doing here, is running that one as a block, running this one as an isolated block, etc. So we won't be doing this once the environment's up and running. This is just so that we can follow along the code and actually see what it brings back. So we assign those variables, that's cool. And then we do some more imports, and this time we're going to get into PySpark. So let's import these SQL functions from PySpark. Now you see automatic compute resource connect success. So that's because when you open a new notebook, you have to connect it to some compute resource. Now we're only going to use this same cluster for each notebook, so it just automatically detects we only have one and assigns that. So that's fine. So now that we have Spark up, this is where we start using things like data frames, which your data frame is essentially just your frame which has your data in it. So data frame, it stores a schema plus the data, essentially. And I'll show you in a moment what that looks like. So data frame equals Spark read option, multi-line true, and it's a JSON file, and this is the file name / location. So if we play that cell, haven't played the first one. Oh, well, good example. What we can do is we can actually just click run all, and it'll just run from the top down, because it has to assign the variable first. Then it'll get to here. So when this is done, we see here that it's created this data frame. And this is the data frame. Now the way to actually see the data frame for us is if we write df and click play, you can see this is the data frame. It has a struct of coordinates, blah blah blah, right, bunch of stuff. So let's have an example of what does it actually look like to us. So we can do .head to get the first one. If we click play, and so then gives back the actual values. So there you go, that's the values. So we have coordinates, this, type that, blah blah blah, URL, etc, etc. So now we're able to see the actual data and see the data frame. So that's perfect. So the first thing I want to do here is reshape the data, because if you just look at this, it's a bit of a mess. Not only because there are loads, but like, I don't even really know what it means. So like coordinates array double type string. I mean, I get it. It's an array of type double. But what are coordinates? So if I mean that from like, if I was a business perspective, I wouldn't be just looking at coordinates. So a way that we can reshape the data is here. We are going to that geometry, column geometry, coordinates, which is this here. Then we're getting item 0. Because it's an array, the indexing starts at 0, not 1. So this is the 0 item. This is the 1 item and 2. Oops. Ugh, there you go. Let's hack it. Let's get rid of that. And then alias, and we're going to call it longitude, latitude, and elevation. Much easier to look at. And then we have properties.title. Instead of that, we don't need properties.title. It's just title. Properties.place, just place. Sig.sig, mag type, time, updated, etc. So now if we run that, see that it's reassigning that same data frame as that same data frame, but selecting only these columns and renaming them. So now if we do df again and run that, you can see that it matches what we've recreated. So we've reshaped the data from this. Let's just drag it down so you can see. Reshape the data from this to this. Much more manageable, and it's got only what we need and nothing more. Perfect. So we can now do that df.head again, and we can see that the data is now looking like this. So there you go. We have an ID, a longitude, latitude, elevation, the title, place description, significance, magnitude, mag type, time, and updated. So looking much better, but Still don't really like that time thing, so we'll get to that in a minute. But it looks much better, much more readable than if we drag this one down. This here. So now you can see the power of data engineering. This is a nightmare to work with. This 100 times better. So next thing I want to do is we want to check for null values. So we are validating the data now. And so it's the same kind of thing. df equals df dot with column. So we're not selecting this time because selecting is basically if you have a table with 100 columns, you only want to select column A, B, C, D. Then now this new data frame only has those columns. We don't want to do a select. We're just saying get these columns and then when it's null, change the value to 0. Otherwise, just leave it as it is. And so this will then run through the data frame and it will affect every single row. We'll click play on that. It will make sure there are no nulls. Whoop, what have we done here? Time, accept and run. Don't see any difference. Must have pasted it wrong or something. So that's fine. No nulls now. That will be good. So now we're getting to the good bit. Let's fix this time, man. So df equals df with column. When it's time, get that column, that time column, divide it by 1000 and cast it to this timestamp. Now that code will change it from seconds into actual time. So if we run that, or actually first let's add the code here. Let's do the df dot head. Oops. Play. Now we've got that there and that's ugly time. If we now run that, then add the code block, and we'll do again df.head, click play. We'll now see that we have a date time object, which has the actual year, etc. So 100 times better to work with than that. Perfect. So now we have this updated data frame. We want to store that as a table. So let's first define the output path. So we want it to go into the silver container, and we'll put it into a folder called earthquake events silver. So click play, and that's just defining the output path. That's not actually moving it over yet. So then the next line, we want to append the data frame to this container using the output path in Parquet format, which is a columnar format. So it stores the data in columns, not as entities, like not in rows. Now this makes for efficient data lookup, but it also Parquet stores schema version history. And so if you change the schema across time, it's good for version control. So click play. And now this will write the data frame, because it's df.write, to this here. And now it's in append because, as you can see, the path doesn't have a date, because the raw file has a date because the raw file is new every day. But the Parquet file, we want that to just continually update because we want to be able to look at the data across time, say if we're visualizing it. So in here, just append because we're just adding to the Parquet file, add these new rows in, for example. And that's that. That's the silver one. So now if we go over here, back to our storage account, and this time go to containers, but go to silver, you'll see we now have this here, which if we open it up, this is our Parquet data. And this here is a Parquet file, and it's a bunch of other files that Parquet likes to have to work. So from here now, we want to create our final notebook, our gold notebook. Let's rename it as Gold Notebook. And this time, let's click in here. First thing I want to do again is to have these variables added in. And as we've spoken about, we will remove these when we get to the data factory so that we can pass the variables in from one to the next. So if we click play on that, that will do the import and then run these. Again, it'll just automatically connect to the only computer that we have. Now, next up, we run this here. So you can see that we have a library that we're not used to having. It's a new library we have, which is this reverse geocoder. So if we click play here, you'll see it will error because it can't find reverse geocoder because it's not a library that's just automatically exists within Python. It's an external library. So if we were to access this external library, we could possibly, because it's Python, we could pip install reverse geocoder. What would be the problem here? Well, it would mean that every time the notebook runs, it would have to install it. Now, do you really want to be managing the libraries like this? Because say someone comes in, they're changing the code, they're like, boop, gone. What happens now? Do we even know if it is installed in the cluster? We would have to check. So it just becomes a bit of a nightmare. So the way that we manage this is we go to compute, and from here we have our cluster. Let's click on our cluster. And now at the top you see we have notebooks that this cluster is attached to. We also have libraries. Now this is the way we can manage libraries without having to deal with pip installs within the notebook directly. So what I want to do is click on install new. And then from here, the library source, we'll use PyPy, which is Py package integration, I think, something like that. Anyway, it's reverse geocoder, and then we'll click install. And this will now install the reverse geocoder library onto our cluster. So it may take a couple of minutes, maybe 5 minutes max, but then it will be within the compute. So if we go back to the workspace, go back to gold, we'll just start filling out the code, and we can run it when the library is installed. So the next thing we do here is we read in the Parquet file, because that's the file that we're going to be interacting with, or the data frame essentially that we're going to be interacting with, to then manipulate it and turn it into the gold final data frame essentially. So we read in that silver data, which is this variable here. So that's the path to the Parquet file. Then I add our next code block. Now, what we're going to add in here is a limit. So we're going to, for our data frame, we don't want the entire data frame, we only want the first 100. Now, the reason for this is because when I was trying to run this with no limit, it was taking too long, taking ages, possibly because we're using a cheap, low spec compute, possibly due to the bottleneck of this external library. Not quite sure, but all I know is that in Fabric it worked faster. So I think it could be something to do with how Databricks is trying to break up the data frame and then run it. But anyway, we're just limiting it to 100 so that we can do it much faster. So this is also good if you're just trying to prove something. So instead of doing the entire data set, you can just try and prove your changes on just a little bit of data so that it's much faster. So what is it we're going to do? Well, we're going to create a user-defined function. And we'll tell you what that means in a moment. I'll tell you what the function is first. So the function is getCountryCode. So we're passing in a latitude and a longitude, and we're defining a function called getCountryCode. And then within here, this is what it does. Retrieves country code for a given latitude and longitude. Parameters returns, and there's an example. And so what it does is it sets coordinates, and then it gets the result by running the search function within RG, which, if you recall from here, we import reverse geocoder as RG. So this is reverse geocoder.search, pass in the coordinates, and then it gives us back the country code. So we have that function defined, but it is a user-defined function. And when you have a user-defined function, you have to register it with Spark to say, I'm going to use this on a data frame. So we have this getCountryCode UDF user-defined function, and it is this user-defined function getCountryCode, and it's of string type. So an example we can try in a minute. It says here getCountryCode. and then just some random coordinates. So let's see if this has installed the library yet. There we go. Yep, installed perfectly. Didn't even have to restart the cluster. Perfect. Let's just click run all then. And it'll run right through all of these down to the bottom, and there you go. So these coordinates, you pass them in to that get country code, and it'll pass us back FR for France. But we don't want to just do it manually like that. We're wanting to use it within the data frame. So we have here a new data frame with location, and we have data frame with column. So a new column, country code, and the value we want to be this get country code UDF, so that user defined function. And we're wanting to pass in these two variables, and whatever the result is from this function is what we're going to assign the value within the column. So, for example here, if we do, or actually let's just run it first, so we'll click play to run. We'll add a new code block underneath, and if we do df dot print schema, how is it doing it again? Print schema, there we go. It's another one for you to know. df.print schema, you can see here, this is the schema. So these are the columns, essentially. If we do the df with location.print schema, and we play this, we'll see that there is a new column, that with column, country code. So if we were to get, say, df.head, you'll see there won't be a country code. But then if we get df with location dot head, it will now have the country code assigned at the end. There we go, code US. So it's going to be much easier now for business users to look at this data and see, based on the country, the number of earthquakes, for example. So now that we have that, we want to classify the significance. So again, we're going to add a column, and this time the column is sig class. So is it low, moderate, or high? So when this column, sig class, is less than 100, it's low. If it's more than 100 but less than 5, it's moderate. And otherwise it's high, so if it's more than 500. Now, this here, something to note on how this runs, and from looking at it, because if you look at it, you're like, well, where's the for each loop? Shouldn't you do for every item in the data frame? That's not how it works. You just create a new column, and it will just automatically do this for every single item. So click play, and then what we could do now is we could check the schema for that, and you'll see that the sig class will exist. So click play. See the sig class exists. Now if we were to run ahead again, you would see that if you were to do the df with location sig class dot head, it would also have this low, moderate, or high. So now we could see countries that have low, moderate, or high, and we could run queries to say how many countries have this number of high, or how many low are within this country, or which country has the most high, most low, etc. So it's much better for aggregation and for grouping now. So now that we have this data, which is much better for the user, let's save it. So we have this gold output path, gold ADLS, earthquake events gold is the folder we're going to use. So we'll just name that. It's just exactly the same as the silver one. And then we'll do another block where we append it. And so again, just so you can see, if we go back to storage count and go to gold, nothing will be in here. If we run this, and then we'll see, oh, I cancelled it by accident. You can see here details, if you follow that, details of what's happening. But it's going to be so fast because it's done that there's no use to actually look into it. But a little tip of information, you can go and look here. Have we look around? Anyway, so now if we go back to gold, refresh, and we'll see, there you go. Oops. Click back in. You can see there it is there. So perfect. And as you can see, you know, if you get a savvy eye, the size is a lot smaller. It's because we're only taking the first 100, as you recall. So if you were to actually run this and you wanted all of the data, because you would, otherwise you've truncated the data, and now if you do a count, it's completely inaccurate. But it's just for demonstration purposes because we want this to run fast. So now that that's been done, we want to go back to Portal, and this time, let's open up Data Factory. Oops. So Azure Data Factories. Again, create here or create from here if it's your first time. We'll click Create. Same subscription, we'll just do the same resource group. The name, we'll just call it Data Look, that's fine. EastUS, that's fine. Blah, blah, blah. Review and create. And then just click Create. And so as I'd spoken about here, is essentially now within Data Factory, we're going to have, within Data Factory, we're going to have this here like this. So notebook 1, notebook 2, notebook 3, and we're going to pass parameters between them, and we're going to automate them to run using Data Factory. And you can make it run based on a bunch of triggers, but the trigger we're going to do is say like every day at midnight, so 0000, rerun this pipeline. So if we go to Data Factory, we'll see that's now deployed. Let's go to Resource and launch Studio, because as I'd said before, it's kind of like its own application. Opens up in a new window. As you can see, it's adf.azure.com. And here's the Data Factory. So there are a bunch of things to look at here. If you want to learn more about Data Factory, if you do a couple of like tutorials like this, you'll learn a fair amount. But if you have specific things you want to learn, you don't know where to start, go to Learning Center, and from here you get quick starts, tutorials, videos, templates, etc. So good to know there. I always find out Microsoft stuff, they always have the learnings, teachings well documented. It's just a well documented system, which is why I was drawn to Azure, especially starting out in my data engineering journey. So if we go to Author, we can see from here, so Home, Author, Monitor, Manage, Learning Center. Learning Center just showing you Manage. We're not going to really do anything here. Home, not going to really do anything here either, to be fair. Author and Monitor. So Author is where we're going to create the pipeline. So under Pipelines, click that, there's nothing there. And if we go to Monitor, there'll be nothing here to monitor, but this is where you would see your pipeline running in action. So if this is ran daily for the past month, we could go on and see when was it successful, when was it not, what were the parameters, etc. So anyway, back to Author. In Pipelines here, click on the three dots, and we're going to go New Pipeline. And this here is your pipeline. So here is kind of like a canvas. You're going to drag and drop things on here, and below is your settings, variables, etc. relative to either, like right now, this is relative to the entire pipeline. But if you were on a specific activity, then it would be relative to that activity. And then on the side here are some properties too. So these are your activities here, things that you can add in so that you can have like some machine learning update resource. Not going to use that, but pretty cool. The stuff you can do, you have Databricks, notebooks, so we're going to use. Then you can have Synapse, you can copy data. So for instance, in the last tutorial, we used copy data to get the data from a SQL server into your data lake. But anyway, today, nice and simple, we're going to just use Notebook. So let's drag and drop onto here. And you can see the properties at the bottom, or the settings, or the stuff about it. And for the name, let's call this Bronze Notebook. Bronze Notebook. And then, that's everything from general. Then let's go to Azure Databricks. So here, we need to create a new Databricks linked service. Because if we click here, nothing. So let's click Create New. And now the reason we're doing this again is this same, the same as this here. So we have Data Factory. Now Data Factory wants to talk to Databricks, not the storage account. Because the storage account talks to Databricks, or Databricks talks to the storage account. but Data Factory only really wants to communicate with Databricks, and then Databricks does this here. So again, you know, principle of least privilege. If everything was open access, it would be like this, but we don't need that connection there. We only need that connection here. So again, it's going to be a two-door stop. A door on each side. So on the Databricks side, we'll go and do that in a moment. We need to create a connector. And then on Data Factory side, we need to create this linked service to be able to link over. So let's go do that now. Within here, we have a linked service. We just call it Azure Databricks 1. That's fine. Connect via integration runtime. Auto-resolve, because they're all within Azure. Just auto-resolves, that's fine. Account selection method, we'll do from Azure subscription. From our subscription, the workspace is our workspace, and then we'll use an existing interactive cluster. So we'll use our, or for me it's Luke Burns cluster, but for you it'll be your name cluster. Authentication type, now we're going to use an access token, but here you can either paste in an access token or use an Azure Key Vault. Now for simplicity's sake, we're just going to use an access token. But if you were to use Key Vault, you would then go and create a Key Vault within Azure. And within that Key Vault, you would then store a secret. So I'll show you kind of roughly what it looks like. Just to get up to speed, because Key Vaults are used a lot for secrets, especially in the real world. Whenever you have a username or a password, things like that, keys which you're going to use multiple times, which can often be bad practice, but secrets, keys, etc. You want a Key Vault. Now click Create Key Vault. You don't have to do this per se. This is just for me to show you. If you want to skip all this and just paste in the key, jump to whatever time's on screen now. But we'll just do data look, so that's the same resource group. Key Vault name, we'll just call it data look, that's fine. And then all that's fine. Let's just review and create. And then create. And what it's going to do is it's going to create essentially a key value pair. Key value pair? Am I getting confused? Is it? Yeah, of course it is. Key value pair storage within Azure. And then what it means is you can be like storing your passwords in there instead of having to store them in text, say. Because the different ways you can store things are essentially you can use a third party to store them, like HashiCorp Vault, or like Key Vault here, or I think it's Secrets Manager in AWS. Or you can store them in plain text in your GitHub repo, which is a surefire way to get A, filed, B, hacked, C, some guy coming and using your resources so that he can mine for Bitcoin or something, costing you a bunch of money. Whatever it is, it's always bad, so don't ever do that. Or you can store it on the computer, so you can export as a variable into your actual operating system. But the problem is if you're using compute and your compute changes every time, then it disappears, right? So the best way to do it is to store it in Azure if you're going to use it again. So if we go to this Key Vault resource, we can see here on the left, let's go to objects. You can store keys, you can store secrets, and you can store certificates. So for the keys example, generate our import, generate an RSA key. So this is like an access key, the one where you get public and a private. Or you can store secrets. This is where you would store an access token. And within here, you can upload manual, just give it a name. Doesn't matter. And here you would paste in your secret value and then click create. And now what it means is you could just continually use that secret value. But as far as I can see, that's not good practice for here, because your access token should be the token for a single piece of access. So let's get this access token. So if we go to Databricks, top right, go to your wee guy, your wee icon, go to settings. Within settings, go down to developer. From developer, we're going to go to access tokens here, click on manage. And then we want to generate a new token. What's this token for? It's for data look, because that's the name everything else has that we've used today. So we'll just call it data look and generate. And there we go. So copy the token now. You won't be able to see it ever again. So let's copy it. Done. It's gone forever. And then paste it in here. And if you're doing the key vault thing. Then you could paste it in there too, but we're not going to do that. We're just going to do it here, paste it in. And now we can choose from existing clusters where we want to link that service to. And it's just my cluster, Litborn's cluster, and click create. And now we have this Databricks linked service linking Data Factory to Databricks. Now, if we go to settings next, now just before we go to settings, we can test this connection here to make sure that it is linked. So click test connection, successful link. So that's perfect. If we were to, just for reference, if we were to use this Azure Key Vault, one thing we would have to do is we'd have to assign the IAM role, because again, on Excalidraw, let's go over here. If you had a Key Vault, again, it's another service within Azure, and you want this to talk to here. Now, based on the way it works here, is that the door from this side is always open, so it's always good, but on this side isn't. So here it's like, yep, this is just fetching out to Key Vault, that's fine. But to get the data from Key Vault over to you, it's the exact same as the storage account here, in which you'd have to go to IAM, you'd have to assign a role. And then once you've assigned that IAM role, then you get the big green tick. And obviously the IAM role, for reference, if you're going to use this, the IAM role would be for the Data Factory, and the roles would be Secret Officer, That's some rough writing, my mouse was sliding, and Secret User. So be able to modify the secrets, but also to read them. No, I don't know. Cut that out. Anyway, back to here. So let's discard the changes. Go to settings. And so settings, we want to set or assign the notebook path. So let's browse. And this is where I was telling you before, like in the workspace. So if you go to shared, which is where ours are. Oh, sorry, not shared, users. Every time I get that wrong. Users, then for me it's my email. From my email, bronze, click OK. There we go, it's now linked to the bronze one. And then let's just copy and paste that. I'm just Command C, Command V, copy paste, copy paste. Let's rename this to silver. And then rename this one to gold. And then we'll change in here. The Databricks linked service, perfectly fine. But we want to change the settings, browse, and we're going to change these to silver and to gold. Silver. And this one to gold. Users. You can also type it in here, but I have had issues before with that. So just for the sake of making sure it works, I'm just going to go through here. I think it's because there's a space. Don't know how it treats that space. Anyway, so we now have these three notebooks. If we were to try and run this, it's like, what order are they running in? Because, you know, it's like, I can just set them like this. Like, what order are they going to run in? So that's why we have, you'll see there's like these little chunks after it here. Well, this one is for on skip. This is for on success. This one is on failure, and this one is on completion. And this allows you to orchestrate the flow of this data pipeline. For us, nice simple data pipeline, it's always on success. And to do that, you just click on it and drag it to the next one. And so now we can validate this, make sure it's all looking good. Then we can debug it. And debugging it will run it, but it won't log it as a run in monitor. It just runs it for you to debug kind of thing. But be aware, because in the notebook we're linking it to the data lake, then it modifies the data in the data lake. So although it is debugging, it's actually just running it, but it just doesn't store the run. So I'm just showing you it just so you know. But anyway, so this is what it will look like anyway if you do run it from here. So if you were to try and run it from here using the trigger, because on this add trigger option, you can trigger now, or you can add a new trigger. We'll add the daily trigger in a moment, but you could just trigger it now and you'll see it here like this. So exactly the same kind of output, and that's successful. Let me talk you through this a little bit. Let's get rid of those properties. So we have I'll collapse these so we can see better. So I have the silver notebook, bronze notebook. After this one's successful, we'll then go into the gold, and that will pop up too. If you go over them, you can see that there's a few little icons. There we go. We'll use this one first because the icons, you can see more come up. So this one here is input. So for here, the only input is the notebook path. When we change to get the parameters from bronze and silver, they will also be in the input. Now, after output, you can then see these glasses pop up. That's good timing. These glasses are a way for you to watch, essentially. And so it gives you a run page URL, which sends you to Databricks, where you can see under data engineering, job runs, you can actually watch it run live. So right now you can see this last one is running, see its status is running. But what this allows you to do is to come here to debug it. So if it fails, you can come to here via the link here, or via just going to job runs, then just selecting one, and you can then follow it through to see. Additionally, you can see the job ID, task, run ID, who run it, when it started, ended, how long it took, and then whether it succeeded. And then you can also see, permissions, compute, and which notebook it is, etc. And you can export it. So very handy to come and have a look. And these values here are what will change in a moment. So as you can see, that has succeeded, which means our static pipeline, so our not so dynamic pipeline, it's kind of dynamic, works. But then the third one, which now has appeared this is your output. So you get the run page URL, which is that there, then it just gives you a bunch of other stuff, which we don't actually require for this here. But good to see it, especially if there's an error, it will tell you in the output what the error is, which saves you having to go here. So that's working now. Let's change this so that we're passing variables from one notebook into another. So the first thing we want to do is to head over to Databricks. We'll shut one down so we've only got one open. We'll go to our workspaces, and let's start with the bronze notebook. So the first thing that we're wanting to do is we scroll down, we have this, remove this before running data factory pipeline. So let's remove that one, and then we'll also delete this, confirm. And so now you see that there's red, you can't really see it actually because of the underscore, but there's a red squiggly line or a orange squiggly line. There you go, you see it. It's saying, what is this? I can't see it because there's no variable declared. So the way that we're going to do it is we're going to get the base parameters like this here. So we have our Databricks utilities, and it's widgets, text, start date, and end date. So we set this as the variable, and then we get the value using this .get, and we assign it to these start and end date variables. Now, the way that this pulls it through is essentially it's creating these variables, and then it's getting the information for them. Now, the way that it gets them is through data factory. So if we go to the notebook, we can see we have base parameters. Now, from base parameters, we can click plus new, and then from here we're wanting to have the name of start date, then click new again, and we'll have another for end date. Now, to get the value for these, on value you can click here and you could just type something in. So like you could have a specific static variable, so like this is the value, but we want to add dynamic content. We don't want it to be just this. value. We want it to change every day because it is the date. So within here, I'll paste that in and I'll talk you through it, is that we're formatting the date and time, and we're going to add days -1, so remove a day from UTC now, and we want it in this year, month, day format because that aligns with our API format, what it expects is in that format. And so that's our, just click OK, that'll give the start, and then the end date is similar, so paste that in, except this time it's just UTC now, so let's remove that add days function. And there we go, and then click OK. So that's the start and end date. And so what this allows you to do then is you're doing a little bit of coding. You can use parameters, system variables, functions, see, look, a bunch of different functions, and actual variables that you have for your pipeline. We don't have any, but you could. To then do a bit of logic, a bit of coding, to then inject the variables in. So that's what we're going to pass in to here. And then pass it in that way. Now at the end here, after we've done everything, we're wanting to pass some of these values so that they can be used in the silver notebook and the gold notebook. So we want to pass in like the silver ADLS to the silver, gold to the gold, etc. So the way that we do that is, let's click code, and this time we're gonna create a dictionary or an object. So we have this output data, and it's going to have the start and end dates, the bronze, silver and gold. However, within base parameters, you can't actually have a value of an object. So what we do is we serialize that dictionary into a string, and then that string, we use this function here to return the string from the notebook, so to push it out as an output, and that's this dbutils notebook exit. And so that's the bronze notebook. We are getting them and then putting them out here. So that's that one done. If we then go to silver, we want to remove this, paste this in. So we're importing JSON, right? And then we're assigning bronze parameters to get the bronze parameters. So these are going to get passed in through the base parameters, which we'll do in a moment. And then we're going to load that as a JSON object back from being that serialized string. So turn it from a string back into an object, meaning that we can then use that output data.get and then pass in what we're after, and it will get the key value. It will get the value based on the key being the start date, and then the value, it will get it in. And now that's because we're turning it back into a JSON. So we have that, and then additionally, at the very bottom, what we're going to pass out, scroll down, click plus code, we're going to output this dbutils notebook exit, and we're going to pass the silver output path because we're going to have to use that within the gold notebook. So if we go to the gold notebook, I'll show you. So if we go back up here, go to gold. Because you can see up the top, we want that silver output path file. So within gold again, let's remove that, the hard-coded stuff, and we'll paste in a similar thing from last time, which is this here, importing the JSON, getting the bronze and silver parameters, and then we are loading the bronze as a JSON object, whereas the silver params, we don't have to because it's just a string as is. And then at the very end, we don't have to output anything because it's the last notebook of them all. So that's the notebooks done. Let's go back over here and see how does that map between each of the notebooks in regards to parameters. So the base parameters for the bronze notebook, that's fine. Start date, end date, that is all that we require. However, now for the silver notebook, what do we pass in here? Well, if we go to the base parameters, click on new, and now this time we're going to pass in, as you recall, bronze parameters. And the value here is going to be dynamic again, and the value itself, we're actually going to pass in this here, this bronze notebook activity outputs, and it's at activity bronze notebook dot output. But we want the run output, and we want to ensure that the whole thing is a string, just like that. Click OK, and that'll pass that bronze parameters into there. If we then go into the gold notebook, we want the same thing again. So let's do bronze params. Just paste it straight in. But we also want silver parameters. And again, paste it in, except this time let's change this to silver notebook output. And we'll click OK. And that's how to pass the parameters through. And so what we can do now is let's publish all. That will save the pipeline. And it will deploy the changes to the factory. And then we'll add a trigger. And when we add the trigger, here we go, we'll get it to run now. So click now, new/edit on add trigger. You can choose your triggers if you've made any. If you haven't, probably haven't. Click plus new. We'll change the name to daily trigger. And then schedule, you can have it as tumbling windows, storage events, custom events. These are things you can go and explore if you want. We're just going to use a normal schedule one. Start date, today, time, that's fine. Recurrence, we want it to run once a day. And let's get it to execute at 00, so bang on midnight. But let's start the trigger now. So if we click OK, and then publish all. So publish that trigger. It doesn't appear to be triggering, don't know why. But what we can do then instead, just to show you, is go and trigger now, and click OK. And then you'll see it will start running. And you can click here, view pipeline run. It will automatically go to monitor and pipeline run. That's because I triggered it now, whereas if it was triggered, so say at 0000, then it will go into this one, triggered runs. But it's in pipeline runs because we just clicked run. And it comes up here just the same as it looked before pretty much. If we click on that here, it will open it up. And there you go. Looks exactly as we're expecting, as we had seen within the author one too. You can view it from here and from here, just as normal. And so this is how to schedule or add a trigger to schedule your pipeline. Right, and there we go. It has now completed that pipeline. So you have done amazing so far. What we have done is we have ingested data using Python within Databricks to get it from an API endpoint into the bronze layer of a Medallion architecture, Azure Data Lake storage container within a storage account. We have then used Databricks to transform this data and clean it into a silver container, then into a gold container, so that it can be used directly for business use. We have then brought these notebooks into Azure Data Factory, abstracted variables out of the notebooks into Data Factory, and orchestrated the pipeline from Data Factory as well. So we've done amazing. If you've gotten this far, comment, I don't know, pineapple or something down below. And if you have as well, please like, comment, subscribe. It's all good, helps the channel grow, helps me learn more by doing more tutorials, and help you by doing more tutorials. And if you would like tutorials early, if you'd like to help decide on which to make next and get emojis on my face and stuff, consider joining the channel as a member. But anyway, let's get back to this. So now that we've done this, let's load the data into Synapse so we can run some queries against it. Now, my initial Synapse deployment seemed to not work, so I've redeployed it. It may take a moment or two, but as soon as it's ready, we'll jump right in. Right, so now that it's complete, let's go to the resource group. And then here you can see all our stuff. Go to this data lake workspace, Synapse workspace, click on this. And from here, we want to open Synapse Studio. So let's click open. And then it pops out here. Same as I was saying before, it's like a different kind of application. And it will just start loading up. And then once it loads up, what we're going to do is we're going to link the database and run queries against it. So this here is the main screen, the home screen. From Synapse Analytics, you can do a bunch of stuff. So you can probably do this entire tutorial in Synapse Analytics, to be fair, because there's a lot of overlap between different services in Azure. But anyway, for us, what we're going to do is on the left, let's go to data. And from data, let's go to linked, and then Azure Data Lake Storage Gen 2, because that's what we linked when we created it. And then from here, if we click down, you can then see the stuff we have. We have Synapse FS, bronze, gold, and silver. So if we click on gold here, what we can do is we can start writing queries against it. So up top, we see new SQL script. So let's do that and select top 100 rows. File type, it's a Parquet file. Click apply. And now we could run this script and it will retrieve the query results and it will put it below. So just take a second to run against it. And there we go. And you can see it's getting back all this information. Now this here, do notice that it's from OPENROWSET. So normally you would have from table name, right? But Parquet isn't a table, it's a file. And so OPENROWSET allows us to open this file of Parquet format as if it were a table. And so that's how we can select this from here. Now, the cool thing about Synapse Analytics is that you can do really quite complex queries. For example, let's paste this one in here, where we are selecting country code and then how many low, how many medium, and how many high from this OPENROWSET data lake. And we're going to group by country code. So for each country, we want to see low, medium, high. And so if we run this, click run. Now what we can do is we could do much more complicated queries. For example, let's do instead, we want the country code and then we want to have, say, count the number of, say, low classifications. So let's do case of when sig class goes low. Oops. I'll paste that and we'll do the same for moderate and high. We'll change them as moderate count and as high count. Add a comma there. Remove that one from this. And then we'll do order by or group by country code. And so what this will do here now is it will select the top 100 of these and it will count the low, moderate and high. So like columns, low, moderate, high and country code. And then for each country code, it will have the number of low, moderate and highs. But we'll just do the top 100 just so that it's a bit faster. And there you go. So from these country codes, which were there, US 258 low, 9 moderate, no high. Then you can see the variety for each one there. So you can see just how powerful leveraging this Synapse Analytics Workspace is, because we can now query our data as if it were a SQL database. So the final thing you can do is a visualization. So you can try and visualize this data in Power BI, because Synapse Analytics is a way to interact with the data, run SQL queries, get some information back. But if you really want to see it, you want to add it into Tableau or Power BI. Power BI, you can't run it on Mac. I'm on Mac, so I can't run it, unfortunately. I could possibly try and run it in Microsoft Fabric, but then it doesn't look like I'm able to get the data from Synapse. I would have to download a hard copy and it'd just be a bit of a faff. So if you do want to put it into Power BI, I have a video which will be carded here and also one of the ones on the side. Go and check that video out and you can do a simple visualization. It's the exact same steps and I'll show you how to do it there. So I do hope you've enjoyed. Any comments, questions, queries, let me know in the comments below. And until next time, take care. Welcome to InTech. My name's Luke and in today's episode we're going to be covering part 5, which is the Power BI visualization of our data engineering end-to-end project in Azure. Now, in previous episodes, we covered the business request as to why you would even do a project like this, the basic architecture, we set up an on-prem SQL database, the services here for the pipeline, Data Factory, Data Lake, Databricks, and Synapse for the extract, transform, and load, and then the setting up of Power BI, which was actually in the first episode. So if you want to follow along, go and watch those episodes. There'll be a card above or a link in the description. Today we're focusing on Power BI, and tomorrow, subscribe for this next episode tomorrow, we're going to be doing the triggering for the pipeline. So how are we going to make this pipeline automatically run every day with the most up-to-date data? So we'll show you that tomorrow and look into the Active Directory as well, so that the relevant people have the relevant levels of access depending on their team or role or group. So without further ado, let's get into Power BI. So in episode 1, I show you how to set up your Power BI because you do need a works email. However, there is a workaround, links in the description of that video on how to do it. Now you can see here as well, app.powerbi.com. If you go on there, you can only change things such as like filters, etc. So you can only interact with dashboards. You can't actually make dashboards from scratch. So for that, you do need the app. And for the app, you do have to have a Windows machine. Now you can try and virtualize it, which is a bit of a nightmare. So honestly, you're probably best to use Tableau if you're going to not have a Windows machine. But best thing to do is to install it and sign up via the link in that there. So anyway, in Power BI, let's open it up. This will be the home screen, and we want to open up a blank report. Now for this blank report, we need data. So let's go up to the top ribbon and we'll go to Get Data. And in here, we want to select More. And when that loads up, if we search in Azure, you see there's a variety of sources we can link to. Now what we want to select is Azure Synapse Analytics SQL, because we want to get the data from there. So if we click on that, we'll click Connect, and some settings will come up and it will say which server is it and which database is it, which is optional. For us, it's that GoDB database from the previous episode. Oops. But for the server name, if we go back to Chrome, we go to the resource group, we go to Synapse, and it's the same SQL endpoint as last time. So settings, properties, serverless SQL endpoint. Copy. Go back to Power BI, paste that in here, and we'll click OK. And here we want to authenticate with our Microsoft account. So let's sign in. This will pop up and you can just sign in as whichever email you were using for your portal. Click Connect. And then this will load the data up. Now as you can see here, it's loading all of the tables. What you can do is you can either load this data or you can transform it. If you transform it, essentially you're creating a series of steps in which the data will always go through whenever it gets updated. So in this example here, if you were to actually transform this data, you could rearrange columns, change types, rename columns, whatever it may be. It can be quite handy. But for us right now, all we'll do is just select all of these tables one by one and load them in. Right, very brief overview of Power BI whilst we're here. Report view, now this is your dashboards view. Table view is a way for you to then view your tables. And model view is where you can then view the data model, which is actually really important and we'll get to in a second. And then lastly, there's DAX query view. So this is where you can write functions to query your data. DAX here being a library of functions and operators. So within Power BI, if we go back to this model here, you can see that it's automatically created a model. Now what it does is it tries to get similar column names, for instance, and say that, oh, this must come from here, that must link to there, such that then if you run queries or filters, that it's able to match things together. Right. Now this is important because you can get, say here, address linked to this customer address table. So if you were to filter, say, by city, that you could then get that reflected in your customers. Now, it's pretty messy. If you're looking at it here, you can't really see much. One thing to note is that these are your tables, and these are the relationships. This is the direction of the relationship, and this is, whether it's one-to-one, one-to-many, many-to-many, whatever it may be. The star indicating many, one being one. So, for instance, here, in the relationship between a customer and an address, one customer can have one address, and one address can have one customer. Now, does that sound about right? Possibly not, because you have multiple customers with the same address if they live at the same place. And so what we can do here is if we go up to the top, we can see manage relationships. That's a much better way to see it. There's the auto detect button, which if we click that, it won't change anything because these are auto detected. There we go. But what we can do then is for that address one, for instance, it's customer address to address. So if we go customer address to address, it's one-to-one. We would probably say that actually, in our case, let's say that would actually be one-to-many. And then for the cross-filter direction, we can have both. Now this is just, as you can tell, filter direction. So you could do just one way, meaning that if you're filtering here, it reflects there, or vice versa. So we'll click save, and that's fine for us. Another thing to note just before we move on to the next one is that an important concept for data engineering, but we'll not cover it in this because this is more about just using Azure for data engineering, is fact and dimension tables. Fact tables essentially contain quantitative data for analysis, whilst dimension tables contain descriptive attributes which are related to the data in the fact table. And so here's a good example of it here, where the fact table has the foreign keys and then these have the primary keys. So there's different locations. This will just say this item is in this location. Then in the location, here's the contact person, where it actually is, blah, blah, blah. So you'll get the gist. And so that's why these relationships are so important. So now if we go back to our report, let's actually build out a little report. So first of all, let's have a quick look at the UI. So here are all the things that you can drag and drop into your report. So different types of graphs, etc. And then a slicer here, which is a filter. And here is all your data. So if you click open any of these tables, it will show you all the columns within the table with an indicator as to what the key is. So first thing we'll add is a card, which is this here. So we click it, it'll pop open a card here. And we have these two parts here, which are further analysis, which we're not going to use, formatting the visual, and then the visuals here, and the fields that you need for it. So if we click on ours here, and then we can click on field, what we can do is let's add product ID. Drag that into field. And you can see here it's automatically chosen count. Now you can do different ones, so you could do sum for instance, but in this instance that doesn't make any sense. Why would you sum it? Whereas you count it, you can then see count of product ID. What we can do here is switch off that category label, that's that count thing there, switch that off. We'll go to general and we can turn on a title, and then we can call this number of products, and then you can see the title pops up there. And then you can do all of this stuff here to change what you want it to be. So colors, background color, blah blah blah, which type of heading. So now we have that card. Let's Control C, Control V. And in this one, let's change this here to the sum of sales. So if we X that out, on the left here, let's go to sales order detail. And we can see line total. Let's drag that in. And it says sum of line total. So it's kind of getting the gist as to what it is. And so sum of line total, if we go into the visual, go to general, title, and we could change this here instead to total sales. So now we have two cards. We have a number of products card, which we can use this here to change size and stuff. And then we have the total sales card. Do that there. Something like this, just for examples as to what you can see. So now if we open back up the context, so we'll go to business rec. Right, so if we come back to the business request to see what's actually creating this dashboard, let's have a look. So, blah, 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 dashboard. This dashboard provides inputs into sales by gender and product category, showing total products, total sales, clear gender split amongst customers, filter by product category and gender. So we can unhighlight that because it's captured in the below more effectively. Let's use a friendly interface for database queries. So we're showing total, right? So we've done that. Now we want to be able to filter by category and gender. And they want to see actually a clear gender split amongst customers as well. So let's first, we'll do a gender split so we'll have some visualizations going on. So we've got Power BI. Let's pick a donut chart here. And in this donut chart, let's do by, if we go to customer, we can try and infer which gender they are based on their title. So if we click title here, we move that into values, and then another one in details. And what that will do now is that will show us the different titles. So here you can quite clearly say that it would appear based on titles that the likelihood is we have majority male customers. But we have a variety of products. We have 295. So which products? So this is where we could add in our filter. So if we go to slicer, oops, Control Z that, Control Z again, let's click out here. We'll create a slicer. Let's create 2 of them. So we'll expand this, make it a bit bigger. This is not for to learn how to do any visualization or best practices. This is just so you can see what's happening. So in here, let's do one with title. So we'll drag that into field. Then we'll do another slicer just for sizing. Whoops. We'll Control C and V. Do the same thing, just going to line it up. And in this one, uncheck that. We'll go to product, category, and we'll go to name. And now we have a variety of product categories. So let's move these 2 here over. We'll move this title one up here, give it smaller. And then we'll do this and we'll make this categories bigger since there are a load of categories. So now in this visualization, what we could do is we could say, what about breaks? What's our split for breaks? So you can see here that breaks affects here. So there's 2 products for breaks and they total 830 say dollars or pounds. But you can see that it's not affecting this. Now that's because of the importance of the model view. Because if we go back to model view, what we'll see here is that there is no connection between customers and category, I suspect. And so if we come back to these relationships, you can see the customer is all alone, not get a relationship to anything. And that'll be why when you update the customer, it's not affecting this. And when you update this, it's not affecting there. So if we go back to relationships, manage relationships, yours might be different because last time mine looked completely different to this. So what we're going to do is we're going to scrap all of them. And then I'm going to create some new relationships. And you can pause the screen and either check yours looks like this, or yours might work out the box, or you can pause the screen and create them yourself. Right, and there we go. If we click close, go back to the report. So now in here, let's make sure that's back on category. If we click breaks, you can see that that's now reflected in both or all 3 of the products, sales, and the chart. And the same up here with title. If we change the title, changes that. So if we say, for instance, let's say, let's scroll, let's just pick something random. Pumps, 2 products, no sales. Panniers, 1 no sales. Locks up, not really selling much, are they? So mountain bikes, there we go. And there's a split here. So we can see that it's 87.5% Mr. title. So 87.5% male gender. likely because it's inferred. And up here we can change it. So let's say we want to see the total sales products that are bought by Mr. Click that. 150k total sales. So there we go. We've now loaded the data into Power BI and we've created a very simple dashboard. So now that we have the dashboard we want, we can then save this as whatever we want, right? Wherever it is, and it saves it as a Power BI workbook. But we can also share or export it. So if you share it, someone else can then access the file, right? Well, what we can do is we can export or publish it. So if we export it, we can do it to PDF to send to people, or we can actually publish it to Power BI. And when we publish it, we will then get a link we can follow, which will then send you to this dashboard where you can interact with it. So if you wanted someone to have a copy of it, an interactive copy, you would send them that published share. Whereas if you just want them to have a PDF, you can export it. Or if you want to share so they can edit it, you can share as well. Now in the next episode, what we're going to do is we're going to go to the pipeline and we're going to create a trigger so that this runs automatically. Because as here it says, we're going to do up-to-date accurate data. So we're going to edit this pipeline or add a trigger which schedules for each day. And then we're going to go to Active Directory and we're going to ensure that only specific people can access specific resources. And I'm going to show you that just so that you have an overview, because we won't need it for this specific project unless, you know, you're going to use this basis to build something bigger on. So anyway, any questions, comments, queries, as usual, put them in the comments below, and I'll see you in the next episode.